diving into our practical credential dumping with CrackMapExec and SecretsDump, it's important to understand how Windows handles authentication and stores sensitive information. Here we have a user that's trying to log into a system. SAM, Security Account Manager, in case this user is trying to log in locally, or the main controller, the DSC, in case this user is trying to log into domain, will verify the credentials of the user. After verifying the credentials of the user, the security identifier of the user, or actually that unique identifier that is used for identifying different users and different groups of that user, will be sent to LSA. LSA, which stands for Local Security Authority, is responsible for enforcing security policies on Windows systems. How exactly does it do? It will use the received SID of the user and it will search that in ACL, Access Control List. In Access Control List, we have different access control entries defining the permissions of the user with that specific SID on specific objects. For example, in ACL, we have some information about the permissions of this user with this specific SID, whether he or she can read any specific file, can write, or can execute any specific file. So, after having a look on the permissions of this user in ACL, our LSA or Local Security Authority will issue access token. This access token will determine that what exactly this user with this specific SID can get access to within the system. And this access token has the SID of the user and the SID of the groups that this user is a member of them. The most important aspect of LSA, which is really important from the point of view of penetration testers, is this, that it will store some credentials in registry. So those credentials are local hashes and domain hashes. And these hashes are stored in a registry, which is a hierarchical database in Windows system that it will store the configuration of the Windows and also all of those sensitive information in it. So these local hashes and domain hashes, which are stored in registry, can only be accessed by the local admin or the user that has system level permission. Assuming that the attacker has the credential of the local admin or user that has system level permission on that system, the attacker can easily use different tools like CrackMapExec or SecretsDump or Mimikatz in order to dump those credentials from registry. And there might be a question in your mind that why exactly the LSA stores these important information, sensitive information in registry. So actually the answer is this, that it stores these credentials on registry in order to make sure that even if the DC is offline, the users can still log into the domain. So it will use these stored credentials, domain hashes that are stored in registry in order to check and verify the credentials of the users trying to log into the domain in that situations. But this is not the only feature of Windows that stores these credentials in registry. We have also an older feature called WDigest that stores credentials in registry. But this time there is a big difference between WDigest and LSA, and that difference is this, that WDigest stores the credentials, the local and domain credentials, in clear text. And that is where the risk is posed to Windows systems. So here, again, the only person that can get access to that information is local admin or the person that has system level permission. And again, if the attacker has the credential of these guys, then he or she can use CrackMapExec and SecretsDumps and related tools in order to dump these clear text credentials from the registry. And WDigest is by default enabled on Windows XP 7, 8, and on Windows Server 2012. and also 2008. So it's really important for patch management in order to turn off the WDigest on these systems. Now that we have understood these core concepts, let's just dive into our practical credential dumping with CrackMapExec and SecretsDump. CrackMapExec is one of the most powerful tools in pass the password and pass the hash attacks. In our scenario, I have one DC and two other systems joined to the domain. And I'm going to use CrackMapExec in order to pass one user password or one user hash to each of these systems in order to see if each of these systems accept that credential. So let's just dive into it. Here we are, and we want to use CrackMapExec. In order to see what protocols work with it, we can simply use --help, and as you can see here, we have gotten a bunch of different protocols working with CrackMapExec, including FTP, WMI, SMB, and etc. In our scenario, I'm going to use SMB protocol. In order to see that what are the switches with this protocol, we can simply get --help with SMB. With any other protocol, you can also get --help, and it will show you the required switches for this protocol. Here we are, and we have gotten some useful switches here, and we can use after CrackMapExec SMB, we can use -u standing for username, P for password, -h for hash in case we do not have the clear text password of the user, -d for the domain, and --local authentication in case we are using a local user account that wants to log in locally. So let's just use CrackMapExec. CrackMapExec with SMB and the IP address of the subnet that we're using in this case, and we have the username called sjobs. Password of this user is Inspire1. I have gathered it in earlier stages. We have -d for domain, which stands here for lab.local. Let's just hit enter and see what we're going to gain. So CrackMapExec has just passed these username and credentials to these three systems. Let's see what has happened here. We have gotten 3 positive here, 3 green positive, which shows that this credential worked in Microsoft, DC, and Apple. So in our DC, in our Microsoft, and in our Apple, these credentials worked. It's fantastic, but we have gotten some bunch of more information here. Is called pond. If you see such a thing, it means that we did not only log into the system with this credential, but this credential was also the local admin of this system. So on Microsoft and on Apple, we have gotten on both of them pond, which means that we were local admin. Great. sjobs with this password is the local admin of these two systems. Now, let's just use CrackMapExec, but this time we're going to use another user, which is actually the administrator. So the local administrator, and I'm going to use -h for the hash. And from previous stages, I have already understood that this lm and ntlm is the hash of this user. So I'm going to paste it here. According to this reason that this user is local user and we're just logging locally, we have to use local auth. So let's just hit enter and see what happens here. CrackMapExec sends this credential to each of these systems, and yeah, have a look here. We have green positive here. We have also pond, which means that administrator was the local admin of Apple. Fantastic. It was also the local admin on Microsoft. We have gotten pond here, but we could not use that in order to log into DC. So this credential did not work in order to log into DC. Okay, and now let's just move on further. We can also use --sam in order to use this local admin in order to dump the local SAM hashes. So let's just see what do we have here. Fantastic. We have gotten those SAM hashes. For example, we have On Microsoft, we have administrator user, the local admin, and LM and NTLM all together. On Apple, we have also gotten that. What else do we have is the guest, the Bill Gates, fantastic on Microsoft, and it's NTLM, so LM and NTLM. And we have also Steve Jobs on Apple, another local user with LM and NTLM. Fantastic. Now let's just use another switch, which is shares. And with this switch, we can just see the shared folders from the point of view of this local user. So let's just have a look. As you can remember, this administrator was the local admin. So what are the shares that are going to be our output? Here we have Microsoft, and the shared folder from the point of view of that is admin CIPC. What else do we have is Apple and these three folders and nothing else. So we can also use that sdrops, the domain user, in order to see what are the shared folders from the point of view of that domain user. So I can use sdrops again, the password, and also the domain name, because we're just logging to domain. And this time we're going to use --shares. Great. Here, as you can see, we have gotten some additional information from the DC, the point of view of DC. We have the shared folder admin, C hack me, and we have also the permissions here, so DC can write and read and write on it. We have these netlogon and also sysvol shared folders. Great, fantastic. Now let's just move further, and I'm going to use again that local administrator, this time in order to dump the LSA hashed credentials stored on registry. So let's just use -h, and I'm again going to copy this and paste it here. Exactly. --local-auth LSA. As you can remember from the earlier explanation, LSA is responsible for enforcing the security policies on Windows systems, and it stores sensitive information on registry. So here we are, and these sensitive informations are available for us in front of us. So we have a bunch of different credentials and hashes dumped out. For example, we have penetration lab.local Bill Gates, this is the user, and this is the SAM, this is the hash of this user. What else do we have? We have penetration lab from the Apple, the system Apple, and that was the last hash that was cached by registry. Or what else do we have? Again, we have gotten a bunch of other different information. Okay, so that was this. Now let's just clean the screen here, and there is also something else, and that's related to SMB-L, capital L, in order to see what kinds of modules are available in CrackMapExec for this specific protocol. So I'm going to hit enter, and you can see that we have gotten a bunch of different modules available for this protocol, including we have Wi-Fi, get key of all wireless interface, we have WDigest, and I have already explained what exactly does it do. It will just dump all of those clear text passwords from the system, from the registry out. And we have gotten also lsassy here. So lsassy is a part of LSA, and it will just dump those hashed credentials out. We have also impersonate, that helps us in order to impersonate and in order to obfuscate our trace as penetration tester or attacker. So yes, we have gotten a bunch of different modules available, but I'm going to use one of those modules called lsassy. For using that, we can simply use CrackMapExec SMB, the IP, user and the hash of the user dash local auth. This time -m for module, and the name of the module I'm going to use is lsassy. So it's also another useful module available with CrackMapExec. So we can see that it will give us some hash credentials here. And yes, that's it. So now let's just move on and have the last point about CrackMapExec, which is its database. CrackMapExec come with something that's called CrackMapExec database, and it simply stores all of the information that we have dumped in a really fantastic way in a table, so well organized. You can just use help here in order to get a clue about what kind of commands are available. So here we have creds, we have hosts, we have also clear database. So I want to just use hosts in order to see them. And if I just minimize it, it's better a little bit. So here we have the IP address, the name of the host, which was DC, the domain of that, penetrationlab.local, even the OS, which was Windows 10, and also it gives us if it was using SME version 1, if it was not, and some other bunch of information about other hosts. Great. We can also get some information by using the command creds, credentials, and it has just really fantastically, it has organized all of those information here for us. For example, we have the username as jobs, and it is in the domain penetrationlab.local. Its password is inspire1. Bill Gates is password 2, and also the hash password of the administrator of Microsoft, and also administrator of Apple in these systems. So that's it. That was this for CrackMapExec. Let's just move on and go to secret dumps. Secret dumps is another tool that we can use for dumping different credentials from the systems. In order to use it, we have to simply type in packet SecretsDump. And in our scenario, the name of the domain is penetrationlab.local, so I'm going to type it like this. And we have the name of the user, which is sjobs. And afterward, we need a colon, and we need to use a single quote and the password of the user. And afterward, we need a sign, and we need to mention the IP address of the system. So I'm going to use 192.168.1.117, and I think that is the IP address of the system in which sjobs is the user of that system. With that, we are going to dump all of the SAM hashes and dump also any domain hashes cached in registries by LSA. So let's just hit enter. Here we are, and we have gained a bunch of different information. Let's just focus. Here it says dumping local SAM hashes. Fantastic. We have got an administrator, the local administrator. We have LM and NTLM. We have guest default and this stuff, but we have also Bill Gates. That's another user. And we have gotten the hash credential of Bill Gates. Fantastic. We have also dumped cached domain logon information. And we have, for example, here penetration lab.local, P Parker, that's a user, it's a domain user, and it is also the hash password of that domain user. We have some other credentials like penetration lab.local administrator. Maybe we have just gained some information about the domain admin, and we have Bill Gates, B Gates, and that's another user, sjobs, and yeah, you have much more information here. Great. Now let's just use a local admin hash in order to do the same task. So for doing that, we are going to use in packet SecretsDump once more. This time you're going to just type the name of that local user, which in this scenario is administrator. And we need to also give the IP address. So I'm going to use again that 117 IP address. And we need to also mention dash hashes. And the hash of that administrator is going to be this. So let's just use this and see what happens. Fantastic. We have gained the same output, so it's not really different. Again, dumping the SAM hashes. And also we have the main login information. So yeah, that was this, and we just simply dumped those credentials both when we only had the hash of the user and when we only had the clear text password of the user. So that was this with SecretsDump, but we can also go further with cracking one of these hashes with Hashcat. In order to crack one of these hashes, we can simply choose one of them, like this one, administrator. So we have LM and NTLM, but in order to crack, the NTLM is enough. We can just grab this part, and I'm going to copy this, and I'm going to create another terminal here. We have to save this hash in a txt file, so I'm going to use nano. I'm going to say hash2.txt. We will paste it here, and afterward we know that it's NTLM, so we have to just understand what is the code that Hashcat use for NTLM algorithm. So every algorithm for hashing has its own code within Hashcat. We have to find it in order to be able to crack it. So we have to use Hashcat --help, and we can grep simply the word NTLM. Here I'm going to use -i because it will ignore if the letters that I have entered as NTLM are capital or are not. So it will just gather all of those for us. Here we have NTLM, and the code for NTLM is 1000. Fantastic. So what we can do simply is we can use Hashcat with the mode 1000, which shows it's going to be NTLM. And we use hash2.txt with the password list, and I'm going to use password list of rocku.txt. User share word lists rocku.txt. Rocku.txt is in this path. And I'm going to also use --show in order to show me the password, and simply it shows the password for us. It is password 1 exclamation. It can be also something more complicated, so no matter, you can just go online and crack it online. So that was this. I hope that you have enjoyed the video. If you have, don't forget to subscribe our channel and hit the bell in order to keep tuned for other videos.